Alright, so I'm going to try to make these videos as short as I possibly can, but it's a lot to go over. We're going to do trigonometric identities notes. If you do not have your notebook out right now or somewhere to take notes, please pause the video and go get it. It is going to be a little on the longer side. These are normally taught, 2 days, 3 days, even a week during Math 3, and we're going to have to hit it all in one day. So this first video is going to be the basics. For most of you guys, just watch this video, do the homework, and just be done. If you're really, really feeling up for it, there are two kind of bonus videos, but I do want to warn you that they're very hard. So if you're someone who, when it gets hard, gets overwhelmed, just skip them. They're not worth it. They're more for those people who really, really just want that extra practice, take it a step further, and might be wanting to major in math or engineering in college. But those videos are not going to be tested on the AP exam. Okay. So kind of our basics, I'm going to kind of write this off on the side. That we really need to kind of understand is this concept of the unit circle. And what the unit circle is we're going to put some point out here, and the x coordinate is going to be cosine of theta, and our y coordinate is going to be sine of theta. And this is for, kind of basically some point where we're imagining that theta, what we're defining theta as, is it's this angle between the x-axis up to that kind of line, right? That line connecting the origin with our point. So theta is that angle. Basically how much did we angle up to get to that point? And so what's going to happen is that we can actually turn this into a right triangle. So we can kind of say, okay, well, the base of our right triangle, that's going left and right, that's our x. That's our x. So that base width would be cosine theta. And then our height would be our y value, right? Our height is going up and down. That would be our y value. Our height would be sine of theta. And what we do is we basically control this point, right? It could be theta is just kind of the angle. So it could be anywhere as far out as we wanted to along that line. Well, we say we want to control that theta so that theta is going to be 1, and that's called our unit circle. So the hypotenuse is 1. Okay? And this allows us to create a lot of these what we call trigonometric identities, which are basically just equivalencies, ways to write it in a different way. So it's basically writing trig, sine, cosine, theta, different ways. We saw some of these yesterday with like cosecant theta was 1 over sine theta, right? We're just writing them different ways. So if you remember back to, really this was, I think, started in Math 1, but you may have seen in Math 2 as well, was SOHCAHTOA, right? And so tangent theta is always opposite divided by hypotenuse. So we're going to kind of start there. So tangent of theta is equal to our opposite side, which in this case the opposite was sine, right? Opposite of theta was sine, divided by our adjacent side, which is cosine. And so you may have seen this identity before. This is by far our most important identity, and that's that tangent theta is always equal to sine theta divided by cosine theta, right? This next one we did yesterday, cosecant theta was 1 over sine theta, secant theta was 1 over cosine theta, and these will work backwards as well, and cotangent of theta is 1 over tangent of theta. Now with this one we're going to actually add a second one, because not only is it 1 over tangent theta, but that's like saying the inverse of tangent. Well, we just learned that tangent is sine over cosine. So if we're going to do the inverse, we can also write this one as cotangent of theta equals 1 over tangent theta. Oops, I messed that up. Equals, right, we're going to flip it. So when we inverse it, we're going to get, instead of sine on top, we're going to get cosine theta over sine theta. All right, so these are kind of those basic ones, and I have a list here. We'll get to it later, but I do want to point out that you can always write these backwards, right? So sine theta is 1 over cosecant theta, but you can write it as cosecant theta is 1 over sine theta. All right, same thing. Cosine theta is 1 over secant, or we can write that secant theta is 1 over cosine. So those work both ways. All right. Now, if you want to pause the video, these kind of top 2 lines, that's kind of everything that we just looked at right now. You can copy those down or you can do it later. But that's everything that we were just kind of looking at. The next ones are going to be what we call the Pythagorean identities. And these are a little bit trickier. Okay. So the Pythagorean identities come from a squared plus b squared equals c squared. So if we look at this, this is a right triangle. So anytime we have a right triangle, we can do a squared plus b squared equals c squared. Right? That's just, we've done that forever. So if we make a as our height and b as our base, and then c as our hypotenuse, we replace a with sine theta squared, and we'll replace b with cosine theta squared, and we'll replace c with 1 squared, and 1 squared is just 1. Now when we write these, we'll write sine squared theta like that. This is just notation, meaning how we write things. A lot of textbooks will write it this way. A lot of times you'll see the AP test write it this way, with the squared right next to the cosine. I want you to be very, very, very careful. If you write it this way that I just wrote, your calculator will give you an error. It'll say syntax error, it won't even register. And that's because technically sine is not a number, right? If you type in sine to your calculator and just hit enter, it's nothing. It's the same thing as if you wrote square root into your calculator. It's not going to give you anything, right? You can't just write square root into your calculator and expect that you're going to get an answer. So you couldn't write square root squared. You wouldn't get an answer. They don't cancel out unless you have something inside of the square root, right? Because they're functions that are doing something to a number or to a variable. So in your calculator, you need to write it this way that I have over here with the squared outside, in a parentheses. But mathematicians are lazy and they don't want to write that every single time. So they have simplified it to kind of write it this kind of easier way. Okay, but just make sure we kind of understand that. If not, we'll go over it again later. We're not using our calculators today anyway, so it's not a big deal yet. Right? Solving for cosine squared, meaning we want to isolate for cosine squared. So if we started off with sine squared theta plus cosine squared theta equal to 1, we'll subtract both sides by sine squared theta. And so that'll isolate us as having cosine squared theta equals 1 minus sine squared theta. So that's another identity. These are identical. They're the same thing, but they're just written slightly differently. We do the same thing with isolating for sine squared. I'm not going to show all the steps, but you would basically just subtract cosine squared to both sides. So we'd start with that highlighted yellow line, and we'd subtract cosine squared to both sides. And we end up with it isolated for sine squared. The next thing we're going to do is a little bit trickier. We're going to divide every single term by cosine squared theta, and we'll see why in a minute. So what we're going to do is we're going to just say, okay, let's divide this by cosine squared theta, cosine squared theta, cosine squared theta. In math, you can always multiply or divide every single term by the same thing without changing. So the reason we're going to do this is when we do that, cosine divided by cosine just becomes 1. And sine divided by cosine, we learned was tangent. But it's not tangent theta in this case, it's tangent squared theta. And 1 over cosine theta, right? 1 over cosine we learned was secant, but it's not secant, it's secant squared in this case. And this will be our next identity. We can isolate this for tangent by just subtracting 1 to both sides. So if we subtract 1 to both sides, we get secant squared theta minus 1. There's another identity. Then we can do the same thing, but we can divide everything by sine squared instead. So when we divide by sine squared, what happens is we have cosine divided by sine. That was kind of the new one we learned about, right? That new one, cosine divided by sine, right? We said was up here, cosine divided by sine was cotangent. So we can do that. So it's not going to be cotangent though, because we have the squared. It's going to be cotangent squared of theta plus 1, right? Sine divided by itself is 1 equals 1 over sine was cosecant, but because we have the squared, we're going to get cosecant squared theta. All right, and sometimes you'll see these written. They might want to isolate, for cosecant. So they might just write it the other way. They might write cosecant squared theta equals, 1 plus cotangent squared theta, right? Or cotangent squared plus 1. But basically, they're just switching the sides. You can always do that, right? They just put the left side first. That's okay. Okay, we're not changing it when we do that at all. So just make sure we're all right with that. It's kind of the concept that, if you had x plus 2 is the same as 2 plus x. Or if you have 4 equal to x, you could, write that as x equals 4, a little bit cleaner. So, don't worry about switching sides, right? Next, if we wanted to isolate for cotangent squared, right, we just subtract the 1 over. And so we get cotangent squared theta equals cosecant squared theta minus 1. And that'll be that, okay? Just kind of some other identities, right? We had up here wrote that cosecant theta was 1 over sine theta. Well, we can write, like I said, sine theta as 1 over cosecant theta, or cosine as 1 over secant theta, or tangent as 1 over cotangent. Those all kind of work the same. So this box here, like I said, the top 2 lines are going to be representing the first kind of stuff we did, and then these bottom 3 lines are all of our Pythagorean identities. Either take a screenshot of this, copy it, pause the video, copy it into your notes. But this is kind of showing all these different ways that we could rewrite this stuff. Okay? And so what we're going to do in our homework is we're going to use these identities to essentially just simplify trig and write it easier. And that's something that on the AP test, sometimes we might have to do a little bit of, not a whole lot. Okay, so it's a little bit like a puzzle. At first, you're going to be like, Mr. Dewar, I have no idea how you're doing this or what to do, or like there isn't really a guide of what step to do next. It's kind of just like a puzzle and figuring it out. But my biggest recommendation to you guys is, besides practicing, the more you practice, you'll start to see the patterns. But my biggest recommendation is, if you ever see a squared, whenever you see a squared, you're probably looking more at these, bottom Pythagorean stuff. But in addition to that is, if you don't have a squared, I like to always try to leave sine and cosine as much as I can. If you have tangent, change that to sine over cosine. If you have cosecant, change it to 1 over sine. But try to leave cosine and sine as much as you can alone, and then cancel out. So in that first one, that's what we're going to do. We have tangent. We're going to write that as sine theta over cosine theta. And cosine theta, we're going to just leave alone. Yeah, you could make it 1 over secant, but that wouldn't really help us here. So these cancel out. I'm going to just put a 1 there. So we get sine theta. That's our answer. All right, next one. Again, what I said is, if we ever see something with a squared in it, we want to be thinking about, hey, let's look at these identities. So 1 minus cosine squared theta, we have written. We can always replace that with whatever's on the opposite side. So we're going to replace that with sine squared theta. Now, cosine squared theta, we could have written as 1 minus sine squared, but that's not going to help us, because we're trying to get things with another pattern that you're going to see is, we really want to try to get sine over cosine, or cosine over sine if we can, because those simplify. So if we can ever get to sine over cosine, we know that becomes tangent. Now in this case, it's not tangent, it's tangent squared, because we have the squared in. Next one, cosine theta times cosecant theta. So like I said, I like to, when I can, leave cosine theta alone and then replace the other ones. So cosecant becomes 1 over sine theta, right? If you can just multiply this to the numerator, but if you really want to, you can write it as a fraction and multiply across. So you get cosine theta over sine theta. And that becomes now not tangent, but when cosine's on top, it becomes cotangent theta, right? If you forget these, just kind of go back up to your table and find, hey, where do I have cosine over sine? Oh, right there, cosine over sine, that's cotangent. Okay. Next one, like I said, I like to, when I can, leave the sine alone. So I'm going to just start off, I'm going to just go one at a time. I'm going to say, hey, I have sine theta times 1 over cosine theta. And I'm going to go ahead and just leave tangent theta alone. I'm not going to move it yet. If we need to, we can replace that with sine over cosine, but I'm going to just go one term at a time. So now I'm going to multiply this, right? That's sine theta over cosine theta all over tangent theta. And then what is sine over cosine, right? We're going to start here. What is sine over cosine? We said that that was tangent theta. So that's tangent theta over tangent theta, which just simplifies to 1. So this entire thing just became 1. That's something that's kind of frustrating, but also kind of fun about trig identities. Is a lot of times we get these long equations or long expressions that just all become 1. All right. Next, we're going to kind of review this and look back to really 8th grade or Math 1 sometimes, which was when we divide fractions, we always multiply by their reciprocal. So that becomes 1 and 2, that becomes 5 and 1, and just multiply across, we get 5 halves. Right? 4/5, we're going to multiply by the reciprocal, 35 over 4. Those cancel to 1 and 1. That's 7 and 1. And we just get 7. Right? I'm going to skip C. I think that one's easy enough. But D, right, if we have just one fraction, we're going to just lollipop the other guy and just 1/2 times flip that other reciprocal 1/2, and we get 1/4. Later on, I'll show you guys a little bit of a more advanced way to do these where we don't have to worry about flipping the reciprocal. But for right now, let's just kind of keep it with what we know how to do. So when we do these examples, right, we're going to end up with some more fractions, and we may have to do stuff like that. So in this case, cosecant theta, we can write as 1 over sine theta. If we just did one at a time and we have cotangent theta, nothing's going to happen. So I'm going to do both of these. Cotangent theta is cosine theta over sine theta. And if you're really good at these, there's a trick where we multiply both sine theta and sine theta. We'll get there, but for right now I'm just going to worry about kind of how we did this. 1 over sine theta times the reciprocal, which will be sine theta over cosine theta. So we multiply by the reciprocal. The sine theta terms cancel out, so we get 1 over cosine theta. Now that's not our answer because we can simplify even more, right? What is 1 over cosine theta? We said that was defined as secant theta. So it's just a big puzzle where we just keep replacing it as much as we can. Okay. Next one, 1 minus cosine squared theta, right? I said whenever we see these squareds, we want to be looking at our identities. So 1 minus cosine squared theta we can rewrite as sine squared of theta, right? So now we have sine squared theta over tangent squared theta. Now let's try to replace, and like I said, we always, if we can, let's try to leave sine and cosine as much as we can. So we're going to have sine squared theta over, now tangent we can write as sine squared theta over cosine squared theta. And now we have a fraction, so we're going to multiply by the reciprocal. If you need to lollipop that guy, you can. So sine squared theta, right, over 1, times, we're going to flip the reciprocal, cosine squared theta over sine squared theta. These guys cancel out, and we just get cosine squared theta. That's our answer. Okay. Hopefully you guys could see that. I don't know if my face was covering it, but if not, there it is if you need to look at it. All right, next one, cosine theta secant theta over tangent theta. Again, I'm going to try to go one at a time as much as I can, leaving cosine theta alone. So secant theta is 1 over cosine theta. And then again, I'm going to leave tangent theta for right now until we need to replace it. So that's cosine theta and cosine theta, they cancel out to 1. So this gives us 1 divided by tangent theta, which is not our answer. We want to replace that with cotangent theta. All right. Next one, sine theta over cosecant theta. Again, I'm going to leave sine theta alone. And cosecant theta we're going to write as 1 over sine theta. So if we need to, lollipop that if you really want to, we get sine theta over 1 times, when we flip the second one, we get sine theta again over 1. And sine theta times sine theta, it's like having x times x, right? What's x times x? It's x squared. Sine theta times sine theta is going to become sine theta squared, right? And if you, had written it like this, sine theta times itself was sine theta squared, that works. This is the same thing, but just the math notation a lot of times will be written with that squared first. Okay, so our homework is going to be 8 questions like this. All right, it kind of looks like this. They're all very simple. I am going to post the answers as well. If you need help, you can log into the office hours. Try it first if you can, but if not, it's not a big deal. Just show up at the office hours and start it right then. That's okay because I'm there for an hour. So if you want to just show up to the office hours and just start working right then, that's totally okay. And then you can do it. If you don't have any questions, you just log off. If you have some questions, you ask them. If you want to be in a breakout room, just let me know who you want to be with, and we'll get that going. I am going to also post 2 bonus videos, but again, I really want to warn you that they're pretty difficult. So I don't mind if you stop here. I don't really want to encourage the bonus videos too much, so they're not going to be extra credit. They're just more for those people who, hey, I really want more practice with this and I want to take it an extra step. I might be interested in doing math in college, engineering in college, or I really, really want to do this more and get more practice out of it. But these bonus videos are not extra credit. They're just essentially harder and more challenging for the people who want that. Okay? Anyways, I will see some of you guys in the office hours, and if not, I will see you on Monday.